We were discussing upward machine yesterday. Listen. In that, how many masses we considered? 2 masses are passing over a smooth fixed pulley. This one is M1 and then M2. Now M1 greater than M2, then what happens? M1 greater than M2 means what happens? M1 will come downwards and then M2 will go in upward direction. With the same acceleration or different acceleration? Same acceleration. This will move down with A and then this will move up with A. Same acceleration only. Now you have to find out the acceleration and also tension in the strings and also tension for the string of the pulley also. That one I did not tell yesterday. Today I will tell that. So first of all, here M1 is going downwards and then M2 is going upwards means obviously on M1 what will act downwards? M1G and then upward what will act? Tension T. Then here M2G upwards again same tension or different tensions are? Same tension. Why? Because there is a same string. Same string means same tension always, so that T will be acting in upward direction. Now if we take the free body diagram of M2, so I will take the free body diagram of M2. Here upward tension is there, downwards M2G is there, another force is there due to the acceleration A. Now I want to write the equation for acceleration. What is that? Upwards, yes. Acceleration is an upward direction. So I want to write the equation for MA means M2A is equals to, what will get? T minus mg. Why? Because acceleration and then tension both are in the same direction. So that T minus m2g. Now if I draw the free body diagram of m1 again, acceleration is down and then m1g down and then tension T is in there in upward direction. Now again m1a is equals to, what I can write? M1a is equals to m1g minus tension T. m1g minus tension T. Now I am just adding those equations. Then what will happen? Tension gets cancelled. Then what is remaining here? M1 plus M2 into A is equals to, what will get here? M1 minus M2 into G. Then A is equals to M1 minus M2 by M1 plus M2 into G. This is the acceleration we will get. Difference of the masses by sum of the masses into G. Always remember like that. So A is equals to M1 minus M2 by M1 plus M2 into G. If I take M2 greater than M1, at that time what happens? M2 greater than M1 nothing but M2 minus M1 we will get. That's the difference. Everything is same only. So difference of the masses by sum of the masses into G. That is a acceleration. Very important formula. Very important. This is about the acceleration. Now I want to get the tension, nothing but what I have to do? I have to substitute this acceleration in any one of the equation. Any equation that might be. So that I will take the first equation. What is the first equation we got? M2A is equals to T minus M2G. M2 into, what is the A value we got? M1 minus M2 by M1 plus M2 into G. I will send M2G this side. Then what is that? Plus M2G is equals to T. Correct as it is. Then T is equals to, which I can take as common? M2G I can take as common. M2G I will take common. Then what is remaining here? M1 minus M2 by M1 plus M2. Here what is remaining? 1. Nothing is there, 1. Now here M2G into, I can take M1 plus M2 as LCM. M1 plus M2 as LCM. Then M1 minus M2 plus M1 plus M2. Correct? Huh? Yes. Then what happens? M2 gets cancelled. Then what is remaining for us? 2M1 and then M2G divided by M1 plus M2. 2M1 M2G by M1 plus M2. This is the tension in the strings. Tension in only one string, I am sorry. One string. What is the tension we got? T is equals to 2M1 M2G by M1 plus M2. Listen again. So here first of all, this is a fixed smooth pulley. For this there is no mass and it is not rotating anywhere. That is very smooth. There is no friction for that. So ideal pulley we call it as. Ideal pulley or massless pulley. So whenever I have taken the ideal pulley, what it will do, nothing but it will just pass the string along with that. Then what happens, nothing but the motion can be done by the bodies either in upward direction or downward direction like this. Yesterday already I have shown you for you people. Now here m1 is there and then m2 is there. I said m1 greater than m2 means m1 will come in downward direction obviously, m2 will go in upward direction. Now I have taken the free body diagram of m2 first of all. For that m2 I have taken tension is there in upward direction and m2g is there in downward direction, so that m2g here and acceleration is there in upward direction. Now you have to write the equation for acceleration, nothing but what will write, ma is equals to, who is supporting for ma here, for acceleration who is supporting, t, so that plus who is opposing here, m2g minus m2g we got. And again I have taken free body diagram of the first one, m1 mass. Then for that again tension is there in upward direction, m1g downwards, and then acceleration is there here. Now acceleration I have written the acceleration equation, m1a is equals to, who is supporting for that, m1g, so that is positive, and who is opposing here, tension is opposing, so that is minus. So here tension gets cancelled whenever I add the equations. I add the equations here. So what is remaining then, m1 plus m2 into a is equals to, here m1g minus m2g, so that what I can write, m1 minus m2 into g. Then I send m1 plus m2 down. So this is the acceleration we got, difference of the masses by sum of the masses into g. Now to get the tension value, I have substituted this acceleration in the equation 1. So that is m2a is equals to t minus m2g. Now for that t is equals to, I want to find out the tension of course. So t is equals to m2a plus m2g. m2 into, what is the a value? Difference of the masses by sum of the masses into g plus m2g. So this difference also always depends on whichever the mass is greater, that will get as plus. Here m1 is greater, so only m1 minus m2. If m2 is greater, nothing but what will do? m2 minus m1, that is easy only. So that here I substituted that and then I have taken m2g outside and taken LCM, cancelled everything, then we got the tension as how much? 2m1 m2 into g by m1 plus m2. Everybody understood, right? Very important formulas, both are very important. Copy that. Here one bench is free, no girls? You can sit there. One member can sit there. Third bench. Go there. You go to the last bench. Can you see the board then? Yes. You go. Now here only you'll sit. You go to that bench. How many have you done yesterday only? Good, very good. Very good. Finished? Next. Next, try the problem. find the tension, find the tension in the string, find the tension in the string which is connected to the pulley and ceiling or fixed support, anything you can take. Now for the above problem only, for the same above problem only. Now look at this. Everything tension, where we got this tension as? String connected to the masses. Correct? This string connected to the masses, in that we got the tension is how much? 2m1 m2 g by m1 plus m2. Now I am asking the tension in the string which is connected to the pulley and then fixed support. So nothing but this tension you have to find out. Here tension you have to find out. Let me take that is T dash. So how to find out the T dash? Nothing but you have to take free body diagram of pulley. So if I take free body diagram of pulley, this is the free body diagram of pulley. Pulley is massless or massive? Massless pulley. So that what is the mass of the pulley here? 0. Mass is 0, nothing but is there any weight on that? There is no weight on that. So that here in this string what is acting here above? Tension T is acting. Let me take that is T dash. Tension T dash is acting. Now in this string already we find out what is the tension here? T only now we got T tension. So I said already, for any ideal string the tension will be same at each and every point, but always tension will act away, not towards. Away. Normal reaction will act towards. Mg also will act away only. Okay, that you have to remember. Now if I see this point, from this point tension is acting in this direction. Okay, what about from this point? In which direction it will act? Here, downward direction. At each and every point there will be a tension in 2 directions. So if I take this point, nothing but upward direction will be there and then downward direction. Always from that point tension is acting. So some masses are pulling that point. One is in upward direction, another is in downward direction. So here if you see, from here there is no string only to indicate the tension. So what happening? The string is there in downward direction, so that I will draw the tension in this direction. Again from this also, again in the downward direction only. Yes, so that here if you take the free body diagram of pulley, the tension is there here in downward direction. Here also the tension is there in downward direction. Why? Because here there is a connection. Always I said that tension will act away from the connection. So here connection is there. So away from that, nothing but obviously in downward direction. To draw the upward direction, is it visible? Is string is visible here? No, that is on the pulley. That is on to the pulley like this. Like this it will be there. So that you cannot indicate the tension. So freely in which direction is this there? Downward direction. So that only I indicated in downward direction. Remember that always tension will be away from the connection. Whatever the forces, every force will be away from the point of contact, otherwise connection. Normal reaction or friction or this one also, tension also. Anything is same. So this tension, 2 tensions are in downward direction and then this is in upward direction. Now tell me, this pulley is moving, otherwise it is in equilibrium. Is pulley is moving? It is not moving anywhere. Why? Because it is connected to the fixed support. So which are moving here? Masses are moving. So that only we got the acceleration for the masses. But the pulley is fixed one here. There is no acceleration for that. Fixed one nothing but it is in rest. Rest nothing but what can I say? In equilibrium? Yes. For the equilibrium, what is the condition for the forces? All upward forces equals to downward forces. So that clearly what I can write here, upward force is what? T dash is equals to downward forces T plus T. Because the pulley is in equilibrium, nothing but that is in rest. I said pulley is massless, so only mg is not acting here. If it is a massive pulley, nothing but mg will act here. Always I said that we will consider ideal pulley only. Now upwards tension T dash is there, downwards T is there in both the sides of the strings. So whenever the pulley is in equilibrium, this is in equilibrium, then at that time all upward forces equals to downward forces, then T dash is equals to downward forces is what? T plus T, then totally will be how much? 2T, then T dash is equals to 2 into what is the T formula here we got? 2 m1 m2 g by m1 plus m2. So for the pulley string, what is the tension means? 4 m1 m2 g by m1 plus m2. This is the answer for that. Everybody understood, right? Here pulley is in equilibrium, so only I consider all upward forces equals to downward forces. If pulley is lifted upwards, then what happens? What will be there for us? Acceleration will be there. Acceleration will be there. So now, copy this. Material. Free body diagram. Free body diagram of pulley. FBD nothing but Facebook dearest friend. Two masses. Write a problem. Two masses are connected. Two masses are connected. Two masses are connected by a weightless cord. A weightless cord passing over a frictionless pulley. Passing over a frictionless pulley. Passing over a frictionless pulley, then find acceleration of 1 kg block and tension in the cord connecting the masses and also find tension in the string connected to the pulley. Within 30 seconds you have to tell the answer. 3.3. 2 by 4. 2 by 4, no, 0.5. 0.5 into 10, yes, 5. 5 is acceleration, then tension 660 by 4. Yes, very good. 15. Acceleration 5, tension 15, tension for the pulley is 30. Those are the answers. You should not take this much time. Direct substitution only. That's done. See that, what is the acceleration formula? Difference of the products, difference of the masses by sum of the masses into g. What's the difference of the masses here? 3 minus 1, 2. 2 divided by sum of the masses is 4. 2 by 4 nothing but how much? 0.5 into g. G value is how much? 10. So that acceleration is how much? 5. That's it, finished. Then after that, tension. Tension is equal to, what is the formula? 2m1 m2 by m1 plus m2. 2 into 3, 6 into g how much? 60. That divided by 3 plus 1 is 4. 60 by 4 nothing but 15 is the tension. Now tension in the above string will be 2 times of this tension only, no? So that is how much? 30. Everybody got the answer, right? Yes, no need to do here. Yes. Then next problem is, what is the problem? Find acceleration of 3 kg block. Find acceleration of 3 kg block, and also find tensions in string 1 and 2 and 3. How much? 1. No. Three blocks are there here. 1. 6.
Acceleration 6.
Later. 8, 2, 6 by 10. Yes, 6. 6 is answer. Minus because you considered in wrong way. 6 is the answer. Acceleration is 6. T1? 32. Uh, 20 minus 3. 8 will come in downward direction. Tension is, acceleration is 1, no? Acceleration is 6, right? Yes, yes. 12, tension, and then 20. Yes, tension is 32. T1 is 32. Then T2 is 50. Yes, T3 is how much? 64. That's correct. Those are the correct answers. Very good. Acceleration 6. Tension T1 is how much? 12, 32 na? 32. And T2 is 50. And then T3 is 64. These are the answers. The easiest method is consider these two as one block only. Then only you can get the answer acceleration. Otherwise you cannot get that. Why? Because you will form 3 equations there. 3 equations will be there. I think 4 unknowns will be there for you. Shall I? Look at the board. T2 you got. I have to do T2 only. For the remaining people, they want T1 also, T3 also. So here, look at the board. You have to consider 2 as a one block only. Is there any problem in that? First, for finding the acceleration. So total mass is how much now? 3 and then 5 nothing but 8. 8 is the total mass. Now for the 8 kg, downwards what is acting? Weight no, weight is how much? 80. And then upward what is acting? Tension. Which string that is? First string. T1. And then here acceleration is there in downward direction. For this acceleration is there in upward direction. Obviously here total mass is how much? 8. So 8 will come in downward direction, 2 will go in upward direction. I am taking this entirely as one block only. So whenever I take entirely as one block only, that one block is connected to which one? First string only, right? So that only here I am taking as tension T1. Shall I redraw the diagram again? See that? Here 8 kg is there like this. 8 kg and then here how much is there? 2 kg is there. Now for this 8 kg, the tension will act in upward direction. What is the tension? T1. Why? Because connected to which string? This is totally first string only. Then here also tension is how much? T1. And then mg is how much here? 80. And then here mg is how much? 20. Then this will come downward direction. This will go in upward direction. Those are the diagrams. So whenever you write the equation for MA, so that what I can write here? 2A is equals to, what we can get? 2A is equals to T1 minus 20. So that T1 minus 20 here. Then 8A is equals to, what I can write? 8A is equals to 80 minus T1. Why? Because acceleration is in the same direction of 80. So that 80 will be positive, other will be negative. So that 80 minus T1. Then what happens here? T1 gets cancelled. Then what is remaining here? 10A is equals to 60. Then A is equals to how much? 6. 6 meters per second square. Otherwise, you can take sum of the difference of the masses by sum of the masses into G. What is the difference between them? 8 minus 2 nothing but 6. Divided by sum is how much? 10. 6 by 10 into G is how much? 10. 10 gets cancelled, you will get 6 directly. Okay. Then again you have to find out the tension T1. For finding the tension T1, you can either substitute this acceleration here. Otherwise, you can use the formula. What is the formula for that? 2 m1 m2 by m1 plus m2. So that T1 is equals to 2 into m1 is how much? 2 and then m2 is 8 divided by m1 plus m2 is how much? 10 into G is also how much? 10. 10 gets cancelled. Here 32 is the T1 we will get. T1 is 32 newtons. Then after the next thing is about the T2 you have to find out. So for finding the T2, you will get here, I think you said wrong answer. This one is wrong, I think. That is wrong. 50 is wrong. 50 is wrong. Why? Because it is having some acceleration. Yes, everything is moving with what acceleration? Acceleration A only, no? So listen here. For the 5 kg, downwards what is acting? 50 is acting. And then here tension is how much here? T2 is the tension. And also it is moving under some acceleration. What is that acceleration here? We got 6 is the acceleration. So if I draw the free body diagram of 5 kg, upwards what is there? Tension T2. Downwards what is there? 50. And then there is an acceleration in downward direction. Now again you have to write the equation for 5A is equals to, what I can write? 5A is equals to 50 minus T2. What is the A value? 6. 5 6 are 30. So that T2 is equals to 50 minus 30. That is how much? 20 newtons. T2 is 20 newtons. Yes. Then T3 is equals to, what is the T3? 2 times of T1. That's it. So that T3 is equals to 2 T1. So 2 into T1 nothing but how much? 32. So the totally will be how much? 64 newtons. Clear? So whenever they have given here, they might be given any number of blocks or here any number of blocks. First of all, take all as a single block only. All the right side blocks are single block and then all the left side blocks are single block only. At that time, it will form the perfect advert machine. You already know the formula. A is equals to m1 minus m2 by m1 plus m2 into G. So that we can get the acceleration easily. You just forget about the remaining blocks. You have to take entirely as one block and then entirely left side as one block you have to take. Then from that we will get the acceleration. By that acceleration, we get the tension in the main string, whichever is connected to the, whichever is passing over the pulley. That is the main string. We will get the tension as tension is equals to 2 m1 m2 by m1 plus m2 into g. Here, for example, if I give 4 number of blocks also, you have to take as what? Entirely as one block, that is m1. Entirely as one block, another is m2. So 2 m1 m2 by m1 plus m2 into g. There we will get the tension in the main string. So whenever we get the tension in the main string, for the remaining bodies, for the remaining tensions, you have to take the free body diagram of each and every body separately. So if I take free body diagram of 5, here second string, no, so what is the tension here? T2 will be there, and also on the 5 kg, what is acting here? Downward direction, weight is acting, so that 50 is the weight, and then downward direction, what is already acting? Acceleration, the body is moving under the acceleration. So that here I can write the free body diagram, 5a is equals to, for that who is supporting? 50 minus T2. From that we will get T2 directly. Why? Because we got the acceleration already. So that is about the T2. Then T3 nothing but what? The 2 times of tension in the main string. Tension in the string which is passing over the pulley. So that is how much here? 64 newtons we got. Everybody understood? Yes? Copy that. Where is yellow color duster, ma? Aleda, better. Draw the diagram properly first. In Yuraja, discussing deeply. "50 is wrong here, this is 20 newtons. And everybody said 50 newtons only. Wow. Finished, huh? Next. Discuss slowly, sir. You are discussing with the class, otherwise with your friend only. Now this is a setup. Here m1 and then m2 is there. Now m2 greater than m1. Then you have to find out the acceleration and then tension in the string. Same string or different strings, sir? Same string. So that what is the acceleration of the blocks and then what is the tension in the string? Same method or different methods, sir? Same method. See that here they have taken the 2 pulleys. Here they have taken only 1 pulley. That's it. 2 masses are there. They are moving under the gravity freely whenever we left the system. And also the string also only single string. So that what here we will not get one thing. What is that? T3 we will not get here. Correct? Everything is same as it is. So here also acceleration for this, it will go in downward direction, A, and then this one will go in upward direction. So A is equals to what we will get here? M2 minus M1 by M1 plus M2 into G. This is acceleration. Tension in the cord is what? Tension is equals to 2M1 M2 by M1 plus M2 into G, yes, of course, into G. That is also one of the different form of outward motion. Copy that. Same method, same as outward motion only. Now this is the next setup. So here I have taken m1 and then m2. m2 is constrained to move. Constrained nothing but what, is restricted to move only in which direction? m2 is restricted to move in which direction? Only in horizontal direction. m1 will move in which direction? Only vertical direction. Now I have to find out the acceleration. Same acceleration will be there or different acceleration? Same acceleration. Whenever I pull this one down, then what happens? It will also move with the same acceleration only. Why? Because this is a frictionless pulley, frictionless table, frictionless surface. So that with whatever the force I am applying here, m1g is applying, of course. So that what happens? It will gain some acceleration. So it will also move with the same acceleration here. You understand, right? Acceleration will be same always. Then you have to find out that acceleration and also the tension. So for finding the acceleration, I said m1 will be greater than m2. m1 greater than m2 means system will move in which direction? m1 will move in downward direction and then m2 will move in the right side direction. Now for m1, what are the forces are acting? Obviously m1g here and then tension T here. Same tension or different tensions are? Same tension. Why? Because same string. So that here also tension T will be there. Of course, from the pulley also tension T will be there in downward direction. Here also tension T will be there. But that is not necessary for us. Why? Because we are considering only free body diagrams of m1 and then m2. Now, here this is moving with acceleration A. Here this is also moving with acceleration A. Now, for m2, another force is there. Another two forces are there. What are that? Normal reaction is one. Another is m2g. But what I can say, vertically the body is in equilibrium. Why? Because vertically it is not lifted up and then it is not coming down. So that vertically it is in equilibrium. So that clearly what I can write, n is equals to mg. They will get cancelled with each other. Why? Because they are acting on the same body. Yes, sir. When both forces can get cancelled with each other, whenever they are acting on the same body. Now, here n is equals to mg. That is finished already. Vertically, we are not at all needed that. Why? Because we have to find out what? Acceleration. Now, here if I draw the free body diagram of m1, m1g is acting in downward direction, acceleration down, and then tension is there in upward direction. Now tell me the equation for this. m1a is equals to m1g minus t, m1g minus t. And also if you draw the free body diagram of m2, tension is there in this direction and then acceleration is there in the right side direction. Some of the people might be take in reverse direction tensions. Don't do like that. Why? Because tension should be always away from the connection. Where there is a connection, from that always it should be away. Okay. So here m2 t is there in this direction, acceleration in this direction. So clearly what I can write, m2a is equals to clearly t. That's it. Nothing is there. There is no other forces. So now here whenever I add, then what get cancelled here? Tension gets cancelled. Here what I can write, m1 plus m2 into a is equals to what is remaining? Only m1g is remaining. Then a is equals to what will get? m1g by m1 plus m2. Now to get the tension, substitute this value in the second equation. That will be easy for us. So clearly what I can write, m1 m2 into g by m1 plus m2. That's it. Finished. This is the acceleration m1g by m1 plus m2. In the upward motion, 2 was hanging. 2 masses was hanging, so that only we got 2 masses here. But here, how many masses are hanging? Only m1 is hanging. So only m1 we will get. If the m2 is hanging, nothing but we will get only m2 here. Remember that. Whichever the mass is hanging, that value only you will get. That mass only you will get here. Then tension is equals to there. 2 was hanging, so that only 2 m1 m2 g by m1 plus m2. Here just m1 m2 g by m1 plus m2. If you remember that upward motion formulas, then you can remember this one easily. Otherwise, if you cannot remember directly, you can do as it is like this. Okay, any method is correct only. Like that. Copy everything. चाहिए Swing. नहीं स्विंग होता ना, करेंगे करेंगे. You feeling better now? Better to sleep. Girls, we can also join, no, till 9:30 study hour. Next week means. Let's hope for the best. Draw the diagram. Find acceleration and then tensions in the strings. Acceleration is 10. 5. Yes. Acceleration is 5. That's correct. Which one? First one or second one? Second one. 50 by 25. Tension will be 25. 25, Then what about the tension 1? T1 is how much? Acceleration how much is said? 5, Then 10. T1 is 10. T2 is 25. A is 5. Those are the values. You should not take so much time for these problems. Why? Because formulas are there in front of you only. Direct substitution. Where there are two masses, then what you have to consider that as? Single mass. That's it. Here single mass you have to consider it as how much? 5 kg. This one also 5 kg only. Actually, the system will move or not move? Tell me that. You are finding the accelerations and then tensions, everything, right? So the system is in equilibrium actually. This is 5 and then this is also 5 only. How it is? It is downward. Now it is 15 newtons. No, it's not possible. Here gravity is acting so that gravity will hold. That gravity will hold. Friction is not there. Frictionless surface. The surface is frictionless surface. Whenever you see here, wait 1 second. Yes, it will move. It will move. Why? Because here normal reaction is cancelling with the mg, right? It will move. Whenever upward motion I have taken, if I take the upward motion, nothing but at that time it will not move. Why? Because both the directions same force is there. So here acceleration is 5 and then T1 is how much? 10. T1 is 10, T2 is 25. Everybody got the answers? Yes. So you have to take on the surface two masses as one mass only, you have to consider it as. So like this you will get the diagram. Whenever you consider, listen here, whenever you consider two masses as single mass, then 5 kg you will get on the table and then next one is 5 kg here. Now what happens? This will move in downward direction and then this will move in this direction. Smooth surface. So that here tension T will be there and then here also tension T will be there. If it is not moving means we will get the acceleration as 0. Don't worry about that. Why? Because we will substitute in the formula. If we take the upward motion At that time, both the directions, if I take 5 kg, 5 kg only, what is the acceleration formula for the upward motion? m1 minus m2 by m1 plus m2 into g. 5 minus 5 becomes 0 here. Directly it will become 0. So here it is not becoming as 0 means there is an acceleration. So here acceleration is there in this direction. Now what I can write here, acceleration formula is A is equals to whichever is hanging, that mass only you have to take. Which is hanging here? 5. So that 5g by 5 plus 5 will be how much? 10. 10g gets cancelled. Acceleration is equals to 5 meters per second square. Acceleration is finished. Then next easiest one is this one only. If I consider 2 kg free body diagram, then on that tension is acting how much tension? T1 tension here. Of course acceleration is there here in this direction. So that what I can write the equation as 2a is equals to T1. That's it, no other forces. So acceleration is how much already? 5. So that T1 is equals to how much? 10 newtons. Then about the T2. About the T2 nothing but this is only no main string. Again you apply the main string formula. What is that tension formula is? M1 M2 G by M1 plus M2. So M1 M2 nothing but how much you'll get? 5 5 25 into G by 5 plus 5 10. 10 G gets cancelled. 25 newtons is the answer for this. Clear? 25 only, no? T2 is 25, T1 is 10 newtons and then A is 5 meters per second square. Those are the answers. Yes, I will give one more problem. Duster handle. Find tensions in all the chords. Find tensions in all the chords. Find tensions in all the chords and normal reaction between 2 kg and 3 kg blocks. Let's do that. We'll continue in the afternoon again. We have class. Evening again we have study hour. I'll try to give one more assignment. Need it? Today you have time, no? Today you solve this one. You complete this one. Tomorrow again we will have study hour. Day after tomorrow also we will have study hour. Then I'll give new assignment. Okay, na?